guys, we are back for lesson 0.2, which is order of operations, which is hopefully something that you are familiar with. And in this lesson, we're just going to focus on starting to look at some more complicated expressions, as well as making sure that we can type it in our calculators correctly. Because the cool thing about the TI-84 is that it will also follow this exact order of operations. And what we need to be careful about is just making sure that we type it in the calculator correctly, because sometimes we don't type exactly what we mean and your calculator doesn't know that. So that brings up the phrase, the calculator is only as smart as the user. It's only going to do exactly what you tell it to. So reviewing that order of operations, we have PEMDAS, or please excuse my dear Aunt Sally, which again, hopefully you're familiar with. The P stands for parentheses, and we're going to start to see a lot of other grouping symbols. So I've listed some examples up here where we have regular old parentheses, meaning I would add this A plus B inside the parentheses before I do anything else in the problem. Other types of grouping symbols can be other things that group operations inside of them, things like a square root or a cube root or a fourth root. Things like absolute value bars. We would need to evaluate the inside of the absolute value bars first before we take the absolute value of them. It acts like parentheses. Kind of looks like parentheses. The numerator and denominator of a fraction also count as a type of grouping. So we would need to add A plus B before we can evaluate that fraction. And finally, I know the E in PEMDAS stands for exponents, but if there's operations inside that exponent, that's going to act like grouping. We need to add those together first before we can apply the exponent properties. So just look out for different types of grouping symbols, and that's probably not all of them, but it's a good start. Okay, E stands for exponents. We'll evaluate any of those exponents. M and D stand for multiplication and division. And again, this is just where we need to be super careful. We need to remember that multiplication and division receive the same priority. They should be done from left to right in whatever order they come. It is not do all the multiplication first, because the M comes first in PEMDAS. So just make sure that you are doing that from left to right, and the same with addition and subtraction. You're going to hear me say a lot, addition and subtraction have the same priority. So we need to do those from left to right. And we'll talk a little bit more about why that's the case with addition and subtraction. Okay, so let's jump right into it. We have simplified the expression. We get to use our graphing calculator on C and D. So let's focus on breaking this down by hand first. So starting with PEMDAS, I can see parentheses, so I am definitely going to be evaluating inside those parentheses first. Within the parentheses, I have both subtraction and an exponent. So according to the order of operations, boop, I need to evaluate that exponent first before I do the subtraction. So I'm going to go ahead and underline that so I can see what I'm doing. And it is so important. I know we don't like writing down every single step, but it is so important that you just copy down the problem and only change one thing at a time. Because if you're just trying to write down only the part that you change, you just write down that 8, that's how a lot of times we make silly mistakes, like forgetting a negative, or just like combining the wrong two things in the wrong order. And we just want to make sure we're not making any of those silly mistakes then. So I'm just going to change one thing at a time, and you'll see me underline that thing that I'm changing so I can keep track of what it is I've changed, and I'm going to copy everything else down exactly the same. Okay, I got rid of those parentheses. Next up is exponents. I do see an exponent, so I need to go ahead and evaluate that. Okay, no more exponents, so multiplication and division. I do see some division here, so I'm going to go ahead and take care of that. Okay, and here is where that addition and subtraction rule comes in. Addition and subtraction have the same priority. So I need to make sure that I do this subtraction first. And I told you we would talk about why. So let's look at that. We end up with 26 plus 9. And then 26 plus 9 is 35. Okay, what if I hadn't done that? What if I had done the addition first? And so I'm going to put this in red so that way we know it's not correct. And I'm just going to copy down the problem. 29 minus 3 plus 9. So if we think about what we did correctly, we're taking away 3 of something. Maybe we're talking about dollars. I have $29. I take away 3, and then I get 9 more, right? Because I'm adding that 9. So what happens when I do this addition first is I have $29, and if I just copy down this subtraction symbol, if I combine these, now I'm taking away 12. But I know that's not what happened. I only lost $3, and then I gained 9 more. I shouldn't be taking away 12. And so what we can do to avoid mistakes with the order of operation, it kind of adds an extra step, but what we can do is think of this instead of 29 minus 3 plus 9. So this is a subtraction symbol, and that's really important for you to understand in the calculator, is that you should type this in with a subtraction symbol, because the subtraction key and the negative key are different on the TI-84. Okay, so this is subtraction. But we can also think of it as a negative that belongs to the 3, because I'm taking those $3 away. So we can think of this as 29 plus negative 3 plus 9. And we can turn that subtraction into adding a negative. So now it's adding a negative. And this isn't something that you actually have to do in every problem. I don't want you to have to change subtraction into adding a negative. It's kind of an unnecessary step, but it is something that you need to recognize just is important, that those really do mean the same thing. And that's why we do addition from left to right, is to avoid those mistakes where we can now combine these first, but notice I'm combining 9 and negative 3. So now I would just be adding 6, and adding 6 to 29 gives me the correct answer. Okay, so that's, again, just, we don't really have to do it, but it's important to me that you understand that concept. Okay, let's move on to the next one, a little bit more straightforward. We're going to go through our order of operations. Okay, parentheses first, and I don't see parentheses, but I do see a grouping symbol, right? So I'm going to look at that grouping symbol. There's really nothing to do on the inside of it, right? That's just a negative 8, so nothing to combine. But now I do need to perform the operation of that absolute value, or that grouping symbol. So I'm going to go ahead and do 4 cubed minus the absolute value of negative 8 is positive 8. Notice this subtraction symbol stays there. That's not inside the absolute value. It's just this guy that goes away. And then I have a times 6 divided by 16. Okay, and now I have an exponent, so I'll go ahead and do that. 4 times 4 is 16. 16 times 4 is 64, I believe. Feel free to correct me. I don't actually have my graphing calculator on me right now. So if that is wrong, I would appreciate if you fix that on your paper for yourself. Okay, now, order of operations, we should do multiplication and division from left to right because they have the same priority. So we're going to go with multiplying those two because it comes first, not just because it's multiplication. We have 48 divided by 16. Now we can go ahead and do that division. 64 minus 48 divided by 16 is 3. We end up with 61. Again, if I got 4 cubed wrong, make sure you fix that, but I'm pretty sure that answer is 61 there. Alrighty, so on C and D, we just need to make sure that we type it in our calculator correctly. I mentioned I don't have mine, so I already wrote the answers down for us. But I also put down just some tips for entering different things in your calculator. We can see that I have, how do I type absolute value? You're going to click math. scroll over to number, or it just says NUM, I think, at the top. And then option number 1 right there should say ABS, which in a shocking turn of events stands for absolute value. So you go ahead and click that and it should show up. As long as you have the color edition, it shows up looking exactly like absolute value bars. And I think you can actually update if you have the Silver Plus. You can update the software, and I can help you with that if you need it. Okay, so type that all in your calculator. If you don't remember or you don't know how to type that fraction bar, I have that note farther down on the notes. That is, you're going to click alpha and then the key right next to it. It says x, t, theta, n, and that will make a little fraction for you, unless if you have the TI 84 Silver Edition, you have to click alpha, and then above alpha you have to click the y equals button, that F1 menu, and you'll see an option to add a fraction if you do that. Okay, so type all that in, make sure that you get -4 for C. Again, type all that in. On D, you should get 29/4. And there's 2 different ways you can do exponents. You can just use that x squared key if you're squaring something. But if you need any other exponent, if you need to cube something or raise something to the 4th power, you can use that little caret that's above the plus, minus, multiply, divide side of the calculator over on the right there. Alrighty, okay. So when we plug in for variables, we need to make sure that we always use parentheses. They're not always necessary, but they're never going to hurt, especially, and I'm going to go ahead and add this note, especially for negatives. That is when it's going to make a huge difference. And if you want to try something in your calculator right now to show why this is so important, try to use your calculator to calculate -2 squared, right? So if I want to do -2 squared, chances are, if you type this in the calculator, you are going to do -2 squared. And we know that -2 squared should equal 4. The problem is if you type it in exactly like this in your calculator is actually going to tell you that this equals -4. And I always have students say that the calculator's wrong. Why is the calculator getting this wrong? And to that I say, the calculator is only as smart as the user. So your calculator is actually doing the order of operations here. Your calculator, so let's think about the order of operations. PEMDAS. Okay, there's no parentheses. There is an exponent, and that exponent is only attached to the 2. This negative really is acting like multiplication. It's a negative times 2, which makes that negative, right? So -2 squared. So your calculator's actually squaring 2 first and then multiplying it by the negative. So, and this is where the parentheses comes in handy, especially for negatives. If you want to do -2 squared in your calculator, you need to type in -2 as 1 unit. And in order to make it 1 unit, you need to put it in parentheses, squared. And if you type it in like this, your calculator will give you the answer that we were looking for. We were looking for +4 if we're squaring -2. Because we know negative times a negative is a positive. Okay, so again, that's just where the calculator is only as smart as the user. We need to be really careful. And in order to be careful, we just need to make sure we use parentheses. Okay, so you can see in example A, we have this expression. We are plugging in 3 for A, -4 for B, 8 for C. I use parentheses for all of them, and that's never going to lead me astray. So if we glance down here, like these parentheses, not really necessary, but they're not going to hurt, right? And it's just a good habit to be in. Okay, so we type all that in, we get our answer, and just something that's good to know, if we wanted that answer as a decimal, which we don't need to, 12/5 is perfectly acceptable. I actually like that better. But if we wanted a decimal, we could go math, and then option number 2 is change to a decimal. Click that, press enter, we end up with 2.4. Hooray! Okay, option number B. We need to remember where those absolute value bars are, and then we just go ahead and type everything in the calculator. Again, being so careful with parentheses because we're trying to square that -3 there. And hopefully we get 52 as the answer. Okay, C. Again, we can see it's pretty straightforward. We can go ahead and solve that. I did that on the left. The answer is 76. But what if there was an extra variable? And I do want you to copy this down in the notes. Okay, what if we had x squared minus y squared, absolute value, minus x, y, z? So I added this z variable. And all the problem tells me is x is -6, y is 8. Okay, so I plug all of those in with parentheses. I'm super careful. I just don't have anything to plug in for this z. So I'm going to leave it. But this is why it is so important that we practice solving some of these order of operations by hand. Because we cannot type in variables like this into the calculator. And actually we can. I'm sure you can find a z on the calculator and type it in. It's just not going to give you the correct answer. It's not going to give you the answer you're expecting. These calculators are not computer algebraic systems, and so they just can't handle variables like that. So we are stuck simplifying this by hand. So we need to go ahead and evaluate the parentheses. And since they're separated, I can go ahead and simplify both of these exponents at the same time. -6 squared is 36. 8 squared is 64. And then, again, since I know that I'm subtracting and the multiplication is going to happen before I do the subtraction, I can go ahead and multiply these. So times -48z. And that kind of saves me some steps. You do need to be really careful if you choose to change more than one thing. This is where I start to see mistakes, is you accidentally combine things that should have been combined somewhere else first. Okay, so 36 minus 64. I do not have my calculator. That is 4 gets up to 40, and then another 24 to 64. So I think that's 28 question mark. And the absolute value of -28 is going to be +28. Again, if that's wrong, please just correct me. My mental math is not always on point. Okay, I have minus a negative, so that's why I changed that to a plus, 48z. And 28 and 48z are not like terms. So this is my final answer. This is just as simple as this answer gets, which is not what you would get even if you typed that z in your calculator. Your calculator is going to put in a value, a random value for z, probably 0. It probably told you the answer to this is 28, which just is not correct. So something to keep in mind, you may see that show up in the future. Okay, but D, we will leave super straightforward. Just make sure you can type this correctly in your calculator. You should get that the answer is 10. Okay. So this kind of circles back to what we were just talking about on example C, is combining like terms. We just need to make sure, 1, we follow the order of operations, and 2, that we only combine terms that are able to be combined. So they have to have matching variables, and those variables have to have matching exponents. Okay. And there's a bunch of different ways to identify this. What I like doing is just underlining. I like, okay, I have 16x and minus 7x. Those are going to combine to 9x. And then minus 11 and plus 10 are the only things that are left. Those are like terms, and we just end up with minus 1. On B, I do see some like terms, but since they're in parentheses, I can't quite combine them yet. I do need to go ahead and distribute this 6. I also need to distribute this subtraction just like it's a negative sign. Okay, so I'm going to end up with 6c minus 12 minus 8c minus 1. Again, I like underlining, so I'm going to underline those like terms. Excuse me. We end up with negative 2c minus 13. And there we go. Again, we need to go ahead and distribute here. Distribute this 3, distribute this negative. 9a minus 15b minus a plus 7b. Okay, I'm going to find like terms, and we end up with 8a. The only two that are left are like terms. They're not always going to be. If those two didn't match, then don't add them together. But they do happen to match, right? Minus 15b plus 7b, we end up with minus 8b. Beautiful. And D, we have another distributing problem, or distribution problem. Distribute, negative 16x minus 8y. Negative times a negative is a positive 15x. Again, negative times a negative is a plus 6y. And like terms. And if you wanted to put a 1 in front of that x, right, because negative 16 plus 15 is going to be negative 1, it's absolutely acceptable for you to write a negative 1x. At this point, it's a little bit Algebra 1 to put the 1 in front, but if it makes you understand it better, I have absolutely no problems with you writing that 1 there. Okay, and on to some ACT and SAT practice, because of course this shows up all over the ACT and SAT. So, for real values of P and R, which of the following expressions is equivalent? And something you'll learn on ACT. We probably didn't need to read all that. I can glance through the problem and see some math, glance through my answer options and kind of just use my intuition that it looks like I'm just combining like terms there. So I didn't have to read the directions, which I know we always say it's best to read directions. Make sure you read the directions. But ACT is all about being fast. And actually an interesting side note is here. Like, why did I do PR and not RP? And a good answer might be, oh, well, because the P was first when I was distributing, which isn't wrong. But actually, we'll talk about this again later. Typically, we want to alphabetize. Our variables. And that just makes it easier to combine like terms or recognize that things are like terms, is if I know that I should put them in alphabetical order always. Then, again, it's just easier to see that terms match. Okay, so like terms, we have P and P. We got 10P, which glancing through my answer options, there's only one answer option that has a 10P. So I could have solved the rest of the problem, but I didn't even have to. Minus PR, minus 8R. Because the order that I solved it anyways, I mean, there's the minus PR, there's the minus 8R. Wasn't even the same order, but ACT is all about being fast. Okay, when x equals negative 1, what's the value here? The more you use your calculator, the faster you're going to be at typing stuff in. And maybe you could do this faster in your head, but if you don't trust yourself in your head, just type it in the calculator. Make sure you use parentheses, though. You will get the wrong answer if you don't use parentheses. So since I don't have my calculator, I'm going to go ahead and do this in my head, and it looks like we have negative 6. But again, mental math, please double check me and make sure that that is actually the right answer. Okay, which of the following expressions is equivalent? Okay, we did not need to read that. We could have just glanced down here, said, oh, looks like I'm combining like terms. Let's do that. Negative 35a plus 7b minus 24b plus 3a. There's two like terms, negative 32a. Glance through my options. Oh, there's two of them. So I do need to keep solving. And then it looks like we have a minus 17b left. So D. Another great calculator problem. When you plug in for variables, I highly encourage you, just be in the habit of adding parentheses. You absolutely do not need them in this problem, but it is just a good habit to be in. Okay, when we add fractions, we have to find a common denominator. That's super annoying. Guess what your calculator will do? Find a common denominator for you and actually simplify it if it's able to be simplified. So let's type this in your calculator. You're going to have to give me a second to do this in my head. 420, I think you end up with 23/5. And your calculator would have done all that work for you. Glance through the answer options, and not a single one of those is 23/5. So what you are going to have to do is double check these answer options and see, this is simplified. Could I unsimplify it to one of these answers? Could I find an equivalent fraction? So just seeing for answer option A, that common denominator is 10. So if I multiply by a creative version of 1, right, because 2 over 2 is 1, and multiplying by 1 doesn't change the value, it's just going to change how it looks, we end up with 46/10. So I got lucky. It was the first answer option. If it hadn't been, I would have tried the next one. I would have been like, oh, it's 25 on bottom. Let's try multiplying by 5 over 5 and see what that equals. But there we go. There is lesson 0.2. Go ahead and you can complete your homework assignment for this. And happy order of operations.